Okay, hello everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 3C. I'm Harshoni, moderator of this session. On behalf of Global Knowledge Research Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you all to the 7th International Conference on ICT for Sustainable and Development Solutions. That's a special note for the presenters that you will be given 8 minutes for the presentation and 2 minutes for the question and answers. And on 7 minutes, I will be raised gentle reminder for the conclude your presentation. And there's a special note for the presenters here. Please stay connected with us till the closing remarks. And if you have any query or any update, please write it down to me in the chat box. And I hope you all enjoyed the knowledgeable and interactive session through the day. And now, just before we get started, I'd like to introduce you all to the chair for this session. Professor Rajan Patel. Dr. Rajan Patel is a professor in the Department of Computer Engineering at Gandhinagar Institute of Technology, Gandhinagar, India. He has more than 16 years of teaching experience in the field of computer science and engineering. His research experience mainly in the domain of network security and intelligent applications. His main area of interest is intelligent data and communication, information security, and IoT in AI with intelligent applications. Welcome, sir.
Thank you.
Now I would like to start with our first. First presenter is Dhruva Arinku, and she is presenting on exploring the scheduling techniques for the RTOs. Dear presenter, you may please start the presentation.
Yeah, good morning, sir. So can you make me the host?
You can now share your screen.
Yes, sir. Sir, is it visible, the screen?
Yes, it is.
Yes. Good morning. I am Dhruva Rinku, Associate Professor from CVR College of Engineering, Hyderabad. And my research work is in developing scheduling algorithm, adaptive learning scheduling algorithm for multi-core architecture. Part of it, I have done the survey of different scheduling algorithms and make them in the group, depends on their scheduling criteria. So I hope and I wish it will be useful for the future scholars to further survey. So, and my other co-authors are my guide, Dr. M. Asharani ma'am, and Y. Krishna Surma. So, as we know, the scheduler in the real-time operating system depends on the temporal parameters like deadline, CPU utilization, response time, turnaround time, and depends on this scheduling criteria. We need to design the scheduling algorithm. So, normally, real-time operating system scheduler can be divided into dynamic and static. Static, as we know, rate monotonic and cyclic. Those are the offline scheduler. But my survey, this particular paper has done survey for the dynamic scheduling algorithm. In that also preemptive dynamic scheduling algorithm, I have done survey. We have done survey for that. So as we know, the scheduling policies are preemptive, non-preemptive, and hybrid. So basically, preemptive scheduling is very important for the real-time embedded system where priorities are very important. To as per the priority, task will get the core for the execution. That scheduler will be decided. And non-preemptive is used for the general system where no task has a priority. So depends on the FCFS or cooperative scheduling. It decides the process to execute on the core. And hybrid is at least one task will get the highest priority. So whenever it occurs, it allowed to run on the core. Scheduler will assign core to that particular task. So particularly this survey is done for the multi-core architecture. As we know that single core, if you see any embedded systems, single core is now reaches threshold, and single core cannot give the, is not meeting the speed. It's not even getting heat problem. So multi-core architecture, if you see the scheduling algorithm, we want to design. So first we should understand the multi-core architecture. So if you take the this dual core, so in that processor has the two cores execution unit, as well as each core has its own local cache, as well as shared cache that is labeled to cache, and of course from system bus, it can communicate with other core through the main bus, main memory. So, of course, the single core schedulings are totally different than the multi-core. In multi-core scheduling, it is divided into two types, partition and the global scheduling. So in partition, normally each core has its own ready queue, and task set will be given to that ready queue, and depends on the whatever scheduling algorithm we are using, like SJF, round robin, or FCFS, or RM, EDF, which we can use it for this same technology, we can use it for the single core. But disadvantage of this partition scheduling algorithm technique is when the one task are assigned to one particular set, it cannot migrate. Right. So if one particular queue is filled up but other queue is not filled up, then also it cannot shift to the other processor. So coming to global scheduling technique for the multi-core, in the global scheduling, we have the global ready queue, and then global scheduler will decide which task should be run on which core, and internal migration is allowed. So this particular survey done for the global scheduler techniques. So after reading so many papers, I have divided this group, segregated the scheduling algorithms into group like earliest deadline first group, least laxity group, hardware architecture dependent algorithms, task characteristics based algorithms, and multi-level feedback queue, which is very famous for the multi-core architecture. Segregated this way, the scheduling algorithm. The reference 1 to 7, I have not mentioned the names of the scholars here, but I have put it in the group and uh, uh, discuss about the different way of improving the scheduling algorithm. So EDF, the traditional EDF scheduling algorithm works with the deadline. Whenever a task has the least deadline, that will get the highest priority and get the core. But here the researchers have mix or combine EDF with another greedy scheduling algorithms and design the better scheduling algorithms. Say ED and LL1 scheduling algorithm is there, where the priority is given to the least deadline as well as least laxity, or say zero laxity. So that task will get highest priority when it is executing. So this is giving better performance than the traditional EDF scheduling algorithm. Say another researcher has combined two greedy algorithms, they EDF as a global as well as internal for the migration in the cores. The researchers has advised the gang scheduling algorithm, which itself is the scheduling algorithm for the parallel. So he has combined those two the scheduling algorithm and give better performance in the overhead time. So whenever system face the overhead, that time it will switch to the this new algorithm. Normally it runs as a traditional ADF algorithm, but whenever overhead occurs, it switched to the this, so where gang scheduling is used for the migration in the for the task into cores, and global is assigned through the EDF algorithm. Say other researchers has combined the DM, that is deadline monotonic scheduling algorithm, with the EDF. So DM is the static algorithm and EDF is the dynamic. So in that again, whenever overhead condition occur, automatically it will switch to the static algorithm. That is DM algorithm. So much preemption is not allowed, because preemption is done the context switching, and it also take the time. So in overhead time, the time is very important. So if we want to allow to meet deadline of the all the tasks, so he has given this idea in that he has this authors have combined the DM as well as EDF, static and dynamic scheduling algorithm, to improve the CPU utilization of the system. In this literature group for the EDF and improve the EDF algorithm, even one researchers has concentrated on fuzzy deadline than the absolute deadline to decide the priority of the task. The multi-core based architecture scheduling 8 to 12 references are grouped in this particular type. So in this, they have concentrated on the hardware. So normally heterogeneous multi-core architecture, big core and small core are normally used in the heterogeneous. So big applications has depends on the core affinity. Depends on the core affinity, which task has run before on one particular core. So to avoid the cache miss rate, because information of the context of that particular task will be available in the level 1 cache. So instead of running on the other core, they check for the cache affinity and when core affinity, and whenever they find the context of that task on that particular level cache, that task will assign to that particular core. That means depends on the history. It will decide the scheduling criteria. And then GEDFH algorithm is the global EDF algorithm with hybrid. The name of that is hybrid scheduling algorithm. So here also, so basically.
Sorry to interrupt you, but you have last 1 minute.
Okay, sir. Yes. So then yes, sir. So in one particular researchers has suggested semi-greedy algorithm instead of the greedy. So avoid the preemption to avoid the context switch. Fairness is also in some particular scheduling algorithm. Fairness is also put aside and concentrated on the preemption. So again, it depends on the application scheduling algorithm has designed. Task characteristic based scheduling algorithms are tasks are periodic as well as the sporadic task. Depends on the type of the task. They have designed the different scheduling algorithms. So like a parallel task has converted into sequential small tasks and run as a EDF scheduling algorithm. One researcher has suggested that to get the better CPU burst criteria. And last is the multi-level feedback queue scheduler 19 to 21, which is very famous for the multi-core architecture. So because it required the different level of the queue with the round robin quantum time. So each queue normally works with the round robin, but disadvantage of the traditional MLFQ is they have the static quantum, or each queue has the static quantum. But researchers have suggested that instead of going for the static, dynamic quantum will be given to the each queue. So that quantum will be calculated with the CPU burst of the running task. So that new burst at the runtime will be calculated, depends on the burst of that particular CPU burst of that particular task minus the queue quantum and arriving time of the task. So depends on that. Every time the new quantum will be given to the task. So it can the starvation of the task, the low priority task will get the starvation problem. That can be avoided by this technique. And reinforcement learning concept has used by the one more researchers. In that, author has designed the adaptive learning scheduling algorithm by learning from the history. So in that, she has take care of all criteria and design the Q equation, the objective equation. It depends on that Q table has designed, and in Q table it has stored the previous history of the execution of the task. So depends on its history, it is getting reward or say punishment. Whichever task is getting reward, it is running on that particular queue, the priority queue, and it is getting the output. So this way we have segregated the task scheduling criteria. But after understanding this research gap, we felt it as say dynamic. No much task is adaptive till now. Now it has started working on the adaptive learning. Depends on history. No scheduling algorithms are giving much output, and which are working on adaptive, not considering all temporal parameters for the embedded real-time hard real-time system. Temporal parameters are very important. We have to work on the temporal parameters. Few are working on deadline. Few are working on the execution time. few researchers are working on the say response time, but combined till now nobody has worked, and we have designed a new scheduling algorithm depends on this literature survey,
Hello.
and which is the new
हाँ
schedule.
हाँ जी.
Yes, yes, sir. Thank
ઓકે,
you.
તો તે છે ને એ સી બ્લોકમાં આવી જાઓ.
Sir, can you say little louder?
હા, ડી.
Hello, sir. Hello, sir.
Sir, if you have any questions for the presenter.
Ma'am, good morning.
Good morning, sir.
Ma'am, I have only one question. You did the survey relevant to the scheduling for the RTOS, right?
Yes, sir.
So in that case, that's okay, fine. But you perform some rigorous work on the done by the other researchers relevant to the scheduling methods, and you found dynamic scheduling that would be a better one, right? So in that case, what I would like to suggesting you, dynamic, that is okay, fine, but you just also perform review the more papers relevant to the machine learning, or say with the help of deep learning. So that would be providing you better way of the scheduling for the real-time operating systems. This is the RTOS, real-time operating system. So in order to provide the real-time performance for the particular any operations or the task, that would be a better one if you provide the efficient kind of the learning, with the help of machine learning techniques, right? So you just think about that. That would be a better one. Huh? Okay.
Yes.
Thank you, ma'am.
Sure, sir. Thank you very much. I'll look into it. Thank you, sir.
Yes,
I will
Harsh.
work on it, sir.
Okay,
Yes.
okay.
Okay,
Thank you. Harsh, sir, next one, please.
Yes, yes, sir.
Thank you, sir.
Next presenter is N. Krishna Raj, and he's presenting on effective heart disease prediction using hybrid machine learning techniques. Dear presenter, you may please start your presentation.
Hello, sir.
Yes, sir. Please.
Sir, can you hear me, sir?
Yes, please.
Yes, sir. So just a minute. So the project is effective heart disease prediction using hybrid machine learning techniques. It was done by myself and Sri Krishna from Sri Krishna College of Technology. We are supervised by our professor, Dr. Krishna Rajan. Next slide. So yeah, the base paper we chose is heart disease prediction using machine learning model, which was a 2021 paper. Next page. So usually it is difficult to identify a heart disease because it contains high risk factors such as diabetes, blood pressure, cholesterol, and many other factors. So it is very difficult to diagnose whether a disease is actually lethal or not. So various techniques in data mining and neural networks have been employed to find out the severity of heart disease among humans. So for literature review, we chose around 4 to 5 papers to analyze what they done previously. Most of them include traditional ANNs, sometimes using multi-criteria decision-making systems, sometimes k-nearest KNN algorithms, etc. Next page. So the problem statement is in our existing medical system, including the hospitals and everything, we collect the data from the patients, and then we use the data for our machine learning model. Next slide. So existing systems have failed to utilize and understand the importance of misdiagnosis. So the problem with misdiagnosis is usually a false negative or false positive. So without considering that, just predicting for the sake of accuracy leads to a misdiagnosis. So that is the main concern that we are addressing in this paper. Next page. So the proposed methodology is it improves the accuracy of a classification algorithm for the Cleveland data. So the data set we choose is from an institute named Cleveland. And with that data set, we are trying to diagnose whether a heart disease, how accurate the heart disease prediction can be. Next slide. So in our existing system, we made some few changes. One of them include using CFS plus PS algorithms, and also we scale our samples to fit our model. Next slide. So in the demo, we build a GUI like application using Java, Java Swing, and first we input the data set, and once we got the data set, we can start uh, using the accuracy. We can start predicting it. Next slide. So it's divided into many parts, the project, I mean. So the first is usually the data pre-processing and data visualization. So the data set is not very organized or very structured. So we had to pre-process the data to include any non-null values. And also we use a Jupyter notebook to visualize the data using Matplotlib and Pandas. And then dimensionality reduction. So from the start, the data set we got was very multidimensional, and it will take much more computing power to actually model and train the data. So we are using a dimensional reduction algorithm. So in that case, we are trying to map our multi-set data to a 2D or a very less lower plane. By doing so, we can save a few resources for computing. The next one is model for carrier identification. That's the algorithm we use for training our model. And then risk prediction, and then classification algorithms. Next slide. So yeah, the data set was taken from Cleveland, which is a training data set. They have a machine learning repository on their website, and we downloaded. And the file is then imported to an Excel spreadsheet, and then we added the corresponding column names and headers. Next slide. Yeah, so the dimensional reduction, as I said, we used two main algorithms. The main point is the data set is outlined in the next slide. Next slide. Yeah, so from the previous demo, once we imported the data set, we can start performing the dimensionality reduction, and then we can also start performing the clustering. So the reason we chose with clustering is that it is easier to actually cluster two types of data. So if it's a diagnosis, we can cluster into one set, and if it is misdiagnosis, we can cluster into a different data set. So the risk prediction is for use we used carrier identification. The main reason for going with risk prediction is it provides a reproducible and an objective diagnosis. So it's not a one-time thing that we are able to achieve such high accuracy. It's almost entirely reproducible. And the results are also comparably very promising. Next slide. This is the demo. First, we import the data set, and then we start performing dimensional reduction, and now we are doing the carrier identification. Next one. So the model for carrier identification, the model we chose to do is a multinomial logistic regression model. The main reason for going with this model is particular is because the logistic regression works really well in this case, because the data set we are trying to do is mostly just a true or false type output. So logistic regression is pretty much the go-to option here. And also the reason we are going for the multinomial is the data set is a bit of high dimensional, and we are also, even though we are trying to lower it dimension using dimensional reduction, multinomial still can work in a better way. And this MLR algorithm, so the classification algorithms, So for clustering, we can have many algorithms such as KNN or any other good classification algorithms. The next slide. So in the demo, after we done all the reductions and CAD algorithm, now we can actually see how the algorithm, the main summary of it. The next slide. So yeah, this is how the project went. So first we load the data set, then we perform pre-processing on data visualization, and then we dimensional reduction, and then data point clustering, and then we actually build the model. And once we build the model, we can actually start predicting on it. And the classification result is of two types. It either can be CAD or it can be no CAD. So yeah, the tools we used is Java, and IDE we used was NetBeans IDE. We already mentioned where we got the data set from. Next slide. Yeah, the next slide. Yeah, so the conclusion is by having this model, it can make the hardest prediction very easy, even though it is supposed to be very challenging and also very important in the medical field. However, the mortality rate can be drastically controlled if we can be detected at the earlier stage, and hence we are hoping this model can uh, help us in some ways. These are the references we used to make the algorithm work.
Hello.
Yeah.
Yes, sir. You just go back second last slide. List of references.
Yeah.
Yes, this one. I think there are 5 or 6 references are there. I think are there. Is it sufficient?
No, sir. It's just for PT. I'm added only 5
Okay, okay,
references.
okay. These are the only for the PPT presentation, na?
Yes, sir. Yes, sir. Yes, sir. For paper, I added almost like a 15,
Okay.
15 references. Like, so 1 5.
Okay, fine. And one more
Just for PPT.
query I have, that is, you just open your proposed flow work. I mean,
Okay,
proposed diagram. Yes, this, no. Back, next. Next. Diagram, proposed diagram.
So you are seeing block diagram or screen?
Yes, block diagram, proposed flow. Yes, this one, right?
Okay, sir.
So in these diagrams, what you are doing, you are just, you are using the hybrid machine learning approach, right? So at that particular stage, you have to give the justifications or say evidence why you use this MLP or say MLR, right?
Yeah, definitely. The reason we chose for this particular algorithm is because we experimented with other
No,
algorithms.
that's fine. You know these things, fine. But you
Yeah,
should highlight it, with citations and justifications. So that would be, strengthen the our work.
yeah, sure.
Okay, fine. Thank you. Okay, thank you, sir. Fine.
Okay, so
Okay, sir.
moving for our next presentation.
So shall I leave, sir? Sir, we need to wait.
Next presenter.
You can leave.
Sorry. Hello.
Hello, is it audible,
Yes,
sir?
sir.
Yes,
Yes.
ma'am. You are audible.
Our next presenter is Reshmi Bhushan, and she's presenting on automated surveillance video analysis with textual descriptions. Please, ma'am, you can start.
Okay. Good morning, all. Myself, Reshmi S. Bhushan, doing research in College of Engineering, Trivandrum. My co-author is Dr. Suresh K. And paper ID is 202, automated surveillance video analysis with textual descriptions. Now, this is the organization of today's presentation.
Ma'am, you have to share your presentation.
Okay. 1 second, sir. Yeah. Share. Can you see the slides?
Yes.
Yeah, okay. So surveillance video analytics, it deals with developing algorithms for monitoring, analyzing, and managing large volumes of surveillance video data, either in real-time mode or recorded mode. And as we know, it's very important to analyze the surveillance video nowadays for traffic monitoring, security of premises, crowd monitoring, and better healthcare. And this intelligent analysis of surveillance video, what we do is we'll find out the abnormal or anomalous events which is occurring in the video. The abnormal events can be defined as those events which rarely occur than the normal events in a predefined environmental setup. And this detection can be either done manually or by automatically. And manual analysis requires huge manpower. It is time consuming and costly. If you automate that using that is, if you try to generate descriptions of video segments in a readable natural language format, great efforts can be reduced. So the attempt of this work is to convert the video segments into natural readable text. Now, the challenges involved in this is we need to identify the object or humans and then track that. Person re-identification and tracking in multiple camera system. Then extraction of video semantics, behavior modeling of detected objects, generation of natural language text descriptions. Now, a brief literature survey of the video captioning technique. That is, the video segment to text conversion is video captioning. And here, the earlier methods were template-based approaches, where we'll be first finding out the objects in the video frames, where then subject, verb, and object triplets were found out, and that is combined using a predefined template from the sentence. Later, deep learning approaches have been evolved, which greatly enhanced the actions which was produced. And in that case, we'll be first using a convolutional neural network for finding out the video representation, visual representations in the video frame. And then we'll be using visual to text translator using a recurrent neural network, LSTM or GRU. GAN can also be used, that is generative adversarial neural networks can also be used for the same process of visual to text conversion. And then attention-based encoder-decoder approaches can be incorporated in that, which improves the production or the creation of textual descriptions. And most recent works concentrate on the transformer models instead of using RNN, LSTM, and GRU, because it speeds up, it helps supports parallel processing, and also it has got inbuilt encoder and decoder models in it. And so the objective of this work is to develop a deep neural architecture that automatically analyzes the surveillance video by considering the global, spatial, semantic, and temporal features with the identification of salient objects in the video for effective textual descriptions, and to develop attention mechanism in both visual as well as text embeddings or ground truth caption embeddings for generating enriched caption videos of the video. Now, this is the architecture of the proposed system. The input surveillance video is first fragmented into segments. Here we have considered only those segments which is having higher motion. And so a motion estimator is incorporated in that. And after the video segments are obtained, then we'll find out, we'll extract out the features from that. That is a visual feature extractor, where we'll be considering the global features, local features, and temporal features, and these features is given to visual to text translator for generating the textual descriptions. So for the video segmentation, I have used a well-known optical flow-based method for finding out the those segments having larger motion. and video caption framework for extracting the global features, local features, and temporal features. I have used ResNet 50, faster RCNN, and 3D ResNet network respectively, and a transformer network for visual to text translation. And this is a detailed structure of the visual to text translation. Here, multi-head attention networks have been used in the transformer, which computes a scale dot product attention with multiple heads. So the visual attentive features, which is obtained from the global feature extraction, local as well as temporal feature extraction, is combined and is given to the multi-head attention, where we can find out the regions of the attentive regions of the visual features. And these attentive visual features, along with the ground truth caption, and that is the ground truth captions, will be first converted to embeddings, that is word vectors using glove embeddings, and it is given to the self attention layer. Here will we find out the most attentive word vectors. From that, again, multi-head attention is used here, and these two will be given to the feed forward network. And finally, you have a softmax classifier which generates the captions based upon the predicted probability. Now the experiments and results, and since surveillance video data sets for captioning is not available, I have trained the deep neural network using the benchmark data set MSR-VTT, which is a generic video captioning data set, having 6,514 videos for training, 497 videos for validation, and 2,990 videos for testing. And the effectiveness is then tested using the 3 surveillance video data sets, Bose, Avenue, and Visuosity. They do not have captions. I have what we do is, after segmenting that the surveillance videos, we have generated manually the captions, and that is taken as the ground truth. Now, these are the implementation details. For the pre-processing of the textual description is done using the natural language processing toolbox NLTK. 300 dimensional globe embeddings have been used. Then model dimension of the multi-head unit was chosen as 512 with a number of heads taken as 8. Severe weight initialization along with ADAM optimization is used for training. And then performance evaluation metrics is the well-known performance evaluation metrics, BLUE, scores, Meteor, and CIDR. BLUE actually simply measures the similarity measurement between the ground truth and the machine generated output. Meteor finds out the harmonic mean of unigram precision and recall, and CIDR discovers the informative words in it as assisted by the humans. And this is the performance comparison of MSR-VTT data set. And compared with the previous state-of-art methods, ours obtained a good blue at 4 score of 40.8, Meteor of 27.4. It stands in second position for Meteor, and CIDR of 48.1. And these are a few samples for the caption generated by the proposed method on MSR-VTT data. The first video we can see, in the first frames, we can see that the ground truth is many fireworks are exploding in the sky, and ours generated that as fireworks are exploding. And these are the details of the various video segments that I have chosen from the
Sorry to interrupt you, but you have last 1 minute.
Video data set. And here, these are the captions generated for the first data set segment. A man and woman are walking and sitting on seats in a chair. Person walk and sit. And this is for the Avenue data set. A man is throwing and catching his bag. A man throwing the bag. And from the Visuosity data set, a man walks to the chair and sits on it. A man sitting on a chair. And here we can see that some sort of semantics cannot be included in the captions generated for the surveillance video. This may be because we have not trained it with a surveillance video data set. As we know, for the deep neural network, it is necessary that we have to train it with a variety of data sets. Then only it will generate a good caption for that. So the conclusion is deep neural network architecture for video caption generation has been proposed, and the effectiveness is tested using 3 surveillance video data sets. The framework is trained with generic videos, so cannot completely extract the embedded semantics, and more accurate descriptions can be generated by training the method with particular videos pertaining to the area of interest. And these are few references. Thank you.
Ma'am. Hello.
Hello.
Yes, just go back. Second one slide. Okay. Next.
Next. Is this?
Next. I want to look, see the references.
You want to see the reference?
Yes, ma'am.
Okay, sir.
Next one. List of references. Hello. List of reference, ma'am.
List.
Not yes.
List of references.
Yeah. These are these.
Okay.
Okay. Okay, fine, ma'am. At present, I don't have any questions. The work is good one, right? Just I want to know the whether you use the latest one references or not. That is my concern.
Yeah, I have just kept a few references for in this slide. I have put that in the latest references. I put that in the paper for literature review.
Fine. Okay.
Thank you, sir.
Thank you, dear presenter. Okay, now moving forward for our next presentation. Reshma S. Pillai, and she's presenting on citation recommendation using deep learning approach.
Yes, sir.
You may please start your presentation.
Sir, is the screen visible?
Yes, it is.
Good morning, everyone. I'm Reshma Spille, an MTech student from Amada Vishwavidyapeetham. My co-author is Deepthi Ella. Today, I'm going to present the topic citation recommendation using deep learning approach. So these are the agendas for today. First of all, we will be covering the introduction part where we will look into what is citation network and why it is important to us, and the problem addressed in the past and a proposed solution in order to tackle those challenges. And we will look into the evaluation metrics that we have used in order to validate our findings. Then we will conclude it with conclusion and bibliography. What is citation network? Citation is a directed graph. By directed graph, we mean a graph which is an ordered pair of vertices. Let's illustrate it with an example. So here we can see that there is a set of nodes which is being connected with each other through some link, which depicts a relation between each of the nodes. So let's consider each of these nodes being a paper which is being published over a period of time. Then we can say that node 3 and node 4 can cite node 1, but the vice versa not possible, because we can always cite a paper which is being published over a period before only, which signifies that it is unidirectional in nature. There are two sorts of citation recommendations available. One is local and other is global. For local citation, the input will be the query or abstract, and the output will be the set of citation that we can do for that particular query and abstract. And the global, for the entire paper, it will be providing the citation. So here in this particular paper, we will be focusing on local citation recommendation. So at present, the scholar's hardest challenge is to cite the corresponding document in his research. There are various traditional methods are there, but those all seems to be very time taking and very ineffective in nature. So we have created a unique strategy for recommending citation using a deep learning approach. So the problem addressed in the past was, first of all, the network proximity. So what happens, like that is usually whenever we are providing we are getting a set of recommendations, the papers will be very most recent. So sometimes a paper will be a kind of extension of the past 10 or 15 years way before paper. So the network proximity plays a vital role, and in order to resolve those challenges, we do have many homogeneous graph integration algorithms. And these algorithms have an issue, like they always considers similar edge types, homogeneous edge types. So using various deep learning convolution neural networks, it's already been proved that we can use this in order to handle multiple relations. And also the search complexity, for one paper, we need to traverse through millions and billions of paper. So taking everything into account, we devised a methodology to address the problem. So this is our proposed method where we have first pre-processed the data set, then we used a clustering approach, which is Gaussian mixture model. Then we generated two models, one is the ANN model and the CNN-LSTM hybrid model. Then we evaluate our performance based on classification and the confusion matrix. Then we find out the best model among them. First of all, Gaussian mixture model. Coming to clustering helps us to group together all the similar data into one particular class. So here Gaussian mixture helps to overcome the traditional drawback of K-means clustering algorithm, as K-means follows a hard clustering approach. So any set of points which is coming to the K-means will be considering it as a circular shape only. So it may not be true in most cases. So we have Gaussian mixture which takes every set of points in any arbitrary shape as it is coming. And K-means also follows a distance-based approach where if a point is near to a cluster, it belongs to that cluster, but it may not be true in almost all cases. So we have Gaussian, which follows a probabilistic model. It's a probabilistic model which, based upon the probability that this particular point will belong to that cluster, it will be falling to the particular clusters. And also here in Gaussian, we do have variation in account with mean also. Here the main idea is the wider the spread, higher the variance. So here we have used multivariate Gaussian distribution, where in order to find the latent variables, we do have expectation maximization, which is being split into two steps like A step and M step. A step will, assuming some points, first of all, M step will be updating the values. So this is our clustered count representation. So here the number of clusters we have took is 20. There's a number of clusters we have generated by using some trial and error method. So after that, coming to our first model, that is ANN, here we have employed 5 dense layers and 3 dropout layers, and the activation function is redo, then followed by the final output softmax layer. So we have used dropout layer, as what happens when the complexity of a model increases, there's a chance that some of the when the model will perform well in training set of data, while coming to testing set of new data, it will be its performance will be degrading. So in order to resolve this challenge, we have used dropout, which automatically will dropping out 20% of the nodes automatically while testing the data. Finally, we used Adam optimizer and optimization technique in order to compute the loss function. So main idea is like we have a ground truth and the estimated truth, and the loss function should be reduced such that we can say that our model is predicting that much accurate to the truth value. So the second model that we have used was CNN-LSTM models. For CNN, we have used is used for feature extraction, whereas LSTM is used for sequence learning. So first of all, what we have to do in CNN is the models can't understand the way we interpret the text. So we need to convert it into some numerical data. So we have used word encoding for we have found all the unique words and stored in a particular vocabulary. And for each of the words regarding, like, depending upon the occurrence of the words, we will be providing some token values. And after providing the token values, but these token values doesn't provide any relationship between the words. So we do have the traditional single hot vector, which provides a relationship between the words. But this single hot vector is like, one hot vector is like, it's kind of a sparse representation. As for except one value, every value will be zeros. Only for one value it will be 1. So we have something much better than that, which is word to vector, which is a kind of dense representation, which will be will helpful for identifying the relationship between the words. Here we have used 2 convolution 1D layers. So convolution 2D is used for image processing. So as it is test classification, we have used 1-dimensional. So here with the kernel size of 3, like we do have a sliding window of 3, and it will be taking the most prominent feature. Extraction will be done. After that, it's then passed to a max pooling layers. Max pooling layers will be taking the maximum among all the features which being derived, it will be taking the maximum most important feature, and then it is being passed to the activation function. So here we also have used batch normalization, as we have a last set of inputs. So it will be taking much kind of error if suppose as it has to go to many kind of layers. So we will be giving our input in as many batches in as many batch sizes. Then we have used dropout layers at 30% to tackle the overfitting problem. We then placed a LSTM on top of it. As we know, LSTM is used for long short-term memory. So it will help to tackle that dependency. Like if suppose one, as it's abstract, if suppose our one word in the first sentence have a dependency with the word which will be coming in the last. So in order to tackle those things, we have used LSTM, which will be using a memory cell. So this is our architecture of a hybrid model. First, we will be doing feature extraction, then these layers, the convolution 1D max pooling, then ReLU, then it's being repeated once again, then the dropout layer, then LSTM, then finally the softmax and ReLU and the softmax layer. So the cosine similarity we have used here in order to find, so once our particular two models have predicted the cluster number, after that predicting the cluster number, we need to find out the, within that cluster, there is a set of papers, and we need to find, based on the similarity score, we need to find within the most 10 prominent papers. So for that purpose, we have used cosine similarity. So here the basic idea is if the distance is less, there's a high degree of similarity, and when the distance is less, there's a low degree of similarity. So here for dataset, we have used Argus dataset, which was about 90 lakh. So from that, we have taken papers from 2015 to 2002 and took some 20,000 samples, and passed towards a set of pre-processing where we trimmed our dataset to only 3 important attributes, and also we converted our uppercase characters to lowercase, and punctuation was removed. Then the particular sentence was tokenized into small tokens. Then the word elimination, like we remove the unnecessary words which doesn't have much sense. Then the evaluation metrics we used was accuracy. We calculated the accuracy, precision, recall, F1 score. We also calculated confusion metric for both models to see which have the lowest false negative and false positive rate. So this is the classification report of our ANN model. So here we have calculated the precision, recall, F1 score for each of these 20 clusters, and we have got the 79% accuracy for the ANN model. And in the same way, we have also calculated the CNN LSTM model where we got 97% accuracy here. So this is the confusion matrix of ANN, which we can see that here the false positive and false negative rate is much higher compared to CNN LSTM, where it is much lower. We can say so, such that we can say that it's predicting much accurately in the hybrid model compared to the simple ANN model. So this is the accuracy comparison for ANN and LSTM models that we had done. So LSTM is showing a 97% of accuracy and ANN is showing 79% of accuracy. So this is our final output. We have 3 attributes like the author's name, title, and the abstract. So this based on the similarity value, we are printing our particular papers. So coming to the conclusion, we still believe that there is room for improvement. So the ideal number of clusters that we took K value as 20, which was a trial and error method. So in practical application, it won't be that much sufficient, So we try to implement DBCN clustering, but with this particular set of data, we were unable to replicate the cluster number. So we just stick with this Gaussian mixture model. In future, one can try to solve this issue by using some other powerful clustering approaches. And also we used a stronger one can also use a stronger bidirectional LSTM in order to tackle long-term reliance in the future aspect. So here the conclusion is like in the citation recommendation field, no one has such made a collaboration with machine learning and deep learning yet. So it will be a stepping stone in the future to put this type of varied combination together. So finally, we will conclude by saying that a hybrid model outperformed ANN model. So these are some of the references which was helpful for the contribution of the generation of this particular paper. That's all. Thank you.
Hello.
Yes, sir.
Ma'am, just go back and open your proposed work. I mean, the proposed work diagram.
Yes, sir.
Yes, ma'am. Here I have one doubt or maybe confusion. Just see the flow of Gaussian mixture model. After that, you are applying the model 1 and model 2. So you are applying both model parallelly?
No, sir. Actually, we do first we pre-process the data set. Then we did a clustering approach. After that, we generated 2 models. One is ANN and CNN LSTM. Right. We tried this clustering with ANN2 and we tried with CNN LSTM2. Then we calculated the classification.
That's fine, but the query is what, the way of flow you are going now. So here it creates the confusion, a little bit confusion relevant to this one. After applying the model, I mean mixture model, what happened? The inputs will be given to the 2 model 1 and model 2, and yes, the outputs of these 2 models that will be give it input to this.
No, sir. Actually, the output of
that's why what you have to do.
Okay,
here you have to provide the it will be goes to the either model 1 or model 2, right?
Okay, sir. Okay.
Yes, or you maybe consider the case 1 and case 2. Case
yes,
1
sir.
That is model 1 and case 2 that is for model 2.
Okay, sir. Here just I was showing like we have got some output from model 1 and model 2. Then we are performing. Then we find out the best model. So in
That's
that way, I
fine, but
generated.
this is the workflow, na? I mean,
Yes,
of your
sir.
proposed approach or the proposed work. So that
Okay,
will
sir.
create the confusion.
Oh,
It
okay,
is
sir. I
not
will look into
possible
it.
ki, output of these two models that will be goes to the parallelly generate the models inputs, and it will be give it output parallelly to the particular evolutions and evaluate the performance based on classifications.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So little bit corrections are required here.
Okay, okay, sir.
Okay,
We'll do it.
thank you.
Thank you, sir.
So moving for our next presenter. Shreya Chaurashia, and she's presenting on environment-based customer trigger detection.
Yes. Hello, good morning. Around the world, more than 300 million people suffers from an asthma, and around 2 lakh people dies due to an asthma attack each year. If an asthmatic is exposed to a trigger, he or she may get an asthma attack, which is a very serious problem. So our project statement is asthma trigger detection. Team members are as follows: Vaishnavi Chakha, Madhvi Dangra, Isha Dhale, Mansi Bhandari, and myself, Shreya Chaurashia. This project is guided by Leena ma'am. This is the agenda for today's PowerPoint presentation. Next slide. Asthma can be triggered and worse by the varieties environmental causes. If someone is suffering with an hyper-responsive airways, he or she may get an asthma attack, which is a very serious problem. So we have taken this as a project. Next slide. So the motivation is basically all of us wants to work on a healthcare domain. After we have been studying, we got to know about the two diseases in our mind, that are diabetes and asthma. Also, after consulting the doctors, we got to know there is no such device for the prevention of an asthma. So the main two factors are first one is the tracking of the triggers for the asthma patients, and the second is that every patient have the different triggers. So finding that. Objectives of the asthma trigger detection is to alert the patients about the environment condition based on the temperature, humidity, carbon monoxide, and the data is stored on the cloud and visualized. Asthma affects the respiratory systems, and the asthma cannot be cured completely, but the proper meditations or the methods to avoid the asthma trigger can control the asthma. After the research study, experts have come to the conclusion that the asthma can be cured, and asthma is basically triggered by three main things, that is environmental, genes, and habitat. So after overviewing all these factors, the genetic factor cannot be controlled by an individual as it is natural. Also, if when someone is suffering in individual family, we cannot say the other peoples in the family would have affected with an asthma. It is due to the other factors which make a person prone to the asthma. The habitat factor can be controlled by an individual, but he or she needs to have a good understanding of the allergics that may trigger an asthma attack. The only other factor left is the environmental factor, which is the source of the majority of the triggers. So our main focus is an environmental factor. So this was the main paper that we have referred throughout that was smart detection of asthmatic environmental with the alert system. So for this, we have decided threshold values. The level of the COs which were as follows: low level is 50 ppm and mid level is 50 ppm and 100 ppm. High level is greater than 100 ppm if the person is not suffering any symptoms, and if he is suffering, then it is dangerous level. So we have the refer many papers which have been added in this table. This is the architecture diagram. Here the sensors are used to calculate the humidity and the carbon monoxide values. These values are read by the Arduino. Further, the data is sent to the ThinkSwitch using a Wi-Fi module ESP8266. This data is visualized on Arduino and dashboard. Firstly, the collection of the gases concentration is done by the NTU7, which is used by carbon monoxide, DHT11 for the temperature and humidity. Data is sent to the Arduino Uno. It is used to apply the logic to collect the concentrations. Also, the digital data is converted to the analog data. Threshold values takes the gas concentration is above. If yes, the output makes the buzzer sounds and the display is the LCD. Our project is split up into the two models. The first one is the temperature and humidity analysis, and the second is the carbon monoxide analysis. We have taken these values from the literature survey, but for the CO values, the theoretical values and the practical values are different. After doing the practical values, the CO values are around 900 ppm. Before deploying the actual sensors, the circuit was done virtually on the Tinkercad, which is using for virtual circuit simulation. So this was our virtually implemented circuit. This is the block diagram where MQ7 sensors, DHT11 sensors are used as an input to the Arduino Uno, and the output is LCD and buzzer. Arduino Uno is the microcontroller. DHT11 for temperature and humidity sensors. MQ7 is a sensor which is used for the carbon monoxide gas. LCD is used for the display. I2C is used to convert the 16-bit pins into the 4-bit pins on the LCD. Buzzer for the sound. Arduino ID for the writing the code. So this is the estimated cost devices. Okay. This was our project plan. References. I will share the video of our thing. So this is the video that we have been testing, and this is for the mosquitoes all-out thing we have tested for the CO. And this is the dashboard that we have been created. This has the field one as in temperature value, second is the gas temperature value, humidity. This shows the 900 ppm. If it is less than, it will show safer, and if it's greater than, it will show red thing. So thank you. That is it.
Hello.
Yes.
Which hello, may I audible?
Yes, yes.
Ma'am, your screen is not visible.
Shall I share it again? Is it visible?
Yes, madam. Now it is visible.
Yeah.
Okay. Okay, fine, ma'am. Thank you.
Thank
Do
you.
you have any questions?
You are asking to me?
Yes, ma'am.
No, I don't have.
Okay, fine.
Thank you.
Okay, so moving for our next presenter, Hari from the Sai area, and he's presenting on detection of diabetes in pregnant ladies using ANS. Is there anyone belong to his paper? So moving forward, next presenter is Aishwarya Banerjee, and she's presenting on IoT-based automatic irrigation scheduling using MQTT protocol. Dear presenter, you may please start your presentation.
Good morning to all of you present here. I am going to present my work on IoT-based automatic irrigation scheduling using the MQTT protocol. We know that the use of water in agricultural field is very necessary, and lack of water causes dryness, and excess use of water results to water wastage. Sometimes this wasted water may also be the reason for water pollution. Therefore, this research aims to solve this problem by using the Internet of Things. It also focuses to start and stop the irrigation process exactly when it is needed. It aims to reduce the water wastage as well as the labor, as well as it helps to save the time. The hardware setup used for this work is a Node MCU ESP8266 microcontroller, a soil moisture sensor, and a pump with a relay. And the software components used here are message queuing telemetry transport protocol, Internet of Things, ThinkSpeak Cloud, and a Arduino IDE, and a developed app which is developed in the MIT App Inventor. In this IoT-based automatic irrigation scheduling, first the soil moisture sensor data is collected with the help of the sensor node. Therefore, these data are sent to the cloud and as well as the mobile app. After that, the data is also accepted by the controller nodes for making a decision whether to turn on or off the pump. Here, 4 sensor nodes are used, which are placed in particular position of the field, and a single controller node is used to control a pump. And the soil moistures are associated with each sensor nodes along with the controller. These are the placement of the sensor nodes in a lemon grass field where at a particular distance all the 4 sensor nodes are placed. And the operation of the pump, whether it will turn on or off, is done with the help of a relay which is associated with the microcontroller. Here the relay acts as the switch whether to turn on or off the pump. After starting the process, all the sensor nodes are set up. Therefore, the Wi-Fi connection is built. After the successful building of Wi-Fi connection, all the nodes are connected to the MQTT server. If the MQTT server is not connected, then we can check that to connect it with the MQTT server again. If the MQTT connection build-up is successful, therefore the data read by the soil moisture sensor by the controller nodes, and then this data are sent to the ThinkSpeak Cloud as well as the mobile app for displaying the result. After that, the data are again read by the controller node for taking a decision. If a certain threshold value is crossed, then the pump turns on, and if the threshold value does not cross, the pump remains turned off. After turning off the pump, we will wait for some time to observe if the threshold value is crossed again. If again it is crossed, the pump will turn on, and if it does not cross, then the pump will turn off automatically. Same situation will happen in case of the pump when it is off. And this is the end of this process. Here we will be able to see the automatic operation of the irrigation scheduling. Here we can see that after a certain time when the field gets wet, the sensor send the data and the pump turns off. Also, we can visualize this data into the ThinkSpeak Cloud channel. Here are 4 sensor moisture data collected from 4 different nodes. This data also can be monitored in live. The value of this data in a particular instant also can be observed. The developed mobile application also shows different sensor moisture values collected from different nodes. It also shows us the status of the pump, whether it is on or off. Also, live monitoring of the data is possible in this application. This application also sends some alert information to the user about the condition of the field, whether it is wet, whether it needs more water, or any urgent situation occurs, so that the person can go and see what the problem is there. And if there is more water needed or it has sufficient water, then the pump will turn off automatically. Benefits of this system over the existing method. This system works with real field data, and the used system consists of 4 different nodes which collects the soil moisture data from different position of the field. Whether in existing methods, it is shown that a single node is used for data collection. This system uses the MQTT protocol, which helps the data combination, sending the data to the cloud or accepting the data back from the cloud makes the system faster. Additionally, it provides the mobile application, which helps to know the status of the irrigation in the field remotely. These are the references used for this paper. Thank you. End of the presentation.
Hello,
Yes, sir.
my voice is audible. Hello.
Yes, sir. It's
Okay,
short.
ma'am. You made a good prototype, but I have one query. That is, you made this prototype with the help of MQTT protocol, right?
Yes, sir.
So why you prefer the MQTT only? At application layer, there are many other protocols are there.
Yes, sir. In our laboratory, when we are starting this protocol, we have applied different type of protocols, such as we have also applied HTTP protocol and observed the
No, ma'am.
performance.
See, HTTP, it is not called IoT protocol, na?
No, sir. We are just using this protocol to observe the speed of the communication of the data.
Yes,
And
that is my concern. That's why I'm asking. You know, we are using, I mean, you are using the MQTT protocol, right? Apart from MQTT protocol, do you know the at application there are only there are also other protocols are there, IoT protocols. Say
yes,
MQTT, then one more COPE. You know.
yes, sir.
So
Sir, we are mainly focused on MQTT because of simultaneous connection of 4 nodes.
see, ma'am, MQTT it's only a kind of the protocol that is push and publish protocol, right? So
Yes.
that will be notify the things. You cannot operate your devices. You just open the proposed work. I mean the diagram of your proposed.
So this
Go
one?
back. No, back. Go back. Yes, this one, right?
Yes, sir.
Now see this in this diagram. Can I operate the on or off the pump through my mobile application?
Yes, sir. You can also do that.
But you just seen diagram, the flow of diagram. Is it possible? नहीं वही diagram में आपने किया, that's fine, but accordingly this diagram it's wrong na?
Yes. That I have not included, sir. I
Yes,
think my
you got my
mistake.
point,
Yes, I got your point. That's my mistake. But
right?
we
So
can
you
also
just,
manually turn on or off the system from the mobile app.
right? So you
Yes.
just upgrade, I mean update, correct your diagrams. That is one my suggestions. And the rest of things, that is fine. You have a ready prototypes, right?
Yes.
With demonstrations. That's a good work. Huh?
Thank you, sir.
Okay, ma'am. Thank you.
Thank you.
The next presenter is again Aishwarya Banerjee, and she's presenting on IoT-based smart monitoring of soil parameters for agriculture field.
Good morning again. Now I am going to present our second work, which is on the IoT-based smart monitoring of soil parameters of agricultural field. In our previous presentation, we have seen that the use of water is very necessary in the field. Like the same way, the use of proper fertilizers is also important in case of the well growth of the crops. To deal with the growing population, it is necessary to have sufficient availability of food. Fertilizers play an important role. Less use of fertilizer can make the plant grow slowly, and excess use of them can kill the plant also. Therefore, it is important to know the proper amount of fertilizer to be applied in the field. Also, the excess use of fertilizer contributes to the environment pollution. To address this problem, a system is developed with some important features. This system collects the nutrient values of the soil such as nitrogen, potassium, and phosphorus, along with the soil moisture content present in the field. Also, it observes the electrical conductivity of the soil water. Another mobile application is developed to analyze all these parameters remotely. And the overall cost of the system gets reduced by using the solar power bank for power consumption of the sensor nodes. Here again, the hardware setup uses a node MCVSP8266 microcontroller and nitrogen, potassium, phosphorus sensor, soil moisture sensor, electrical conductivity sensor, and a soil power bank. Again, the MQTT protocol is used, and cloud used is the ThinkSpeak one, and the app invented is again a MIT app inventor. Here, all the sensors are connected with the sensor node. That means they use 3 different type of sensors are connected with the nodes, and therefore the data collected by the controller is sent to the cloud server. The communication between the controller node and the NPK sensor is done with the help of a Modbus RX485 TTL converter. After starting, all the sensor nodes are connected with the internet, and again the MQTT connection is built up. If the client is not connected, then we will again check for the connection with the MQTT. If the client is connected, then all the sensor will start reading the data such as the NPK sensor, electrical conductivity sensor, as well as the soil moisture sensor. Again, these data are sent to the cloud, and as well as the mobile application to the user. After analyzing this data, the user or the farmer also can decide how much amount of fertilizer is to apply in the field. Here the hardware setup for the NPK sensor is shown. This sensor helps us to get the particular amount of the nitrogen, phosphorus, and potassium present in the field. The data observed in the ThinkSpeak cloud also presented here. The electrical conductivity sensor helps us to observe the electrical conductivity present in the soil as well as the salinity of the soil. Based on this information, the farmer can decide whether to drain out the excess soil and whether to plant any type of crop which is suitable for that particular field. The soil moisture sensor also helps us to know the water content present in the field. That also will depend on the type of the crop, which type of crop will be best suitable for this particular field or not. That information is again valuable for the farmers. Another app is developed which is named as a Farm Doc app. Here in this app, we can observe all these collected nutrients remotely from any places. Here the live visualization of the collection of data in the ThinkSpeak cloud is observed. We can see that according to time, the data are updated in the cloud, which can be observed from any places of the world. Similarly, the data visualization of the Farm Doc app also can be observed here. Here, by scrolling the screen, we can get the information of the all parameters present in the soil, such as the NPK, electrical conductivity, and many more. This system helps in live monitoring of the soil parameters, which is possible from any places around the world. It again uses many nodes to collect the data at a time instead of a single node like the existing method. The proposed system uses the MQTT communication for fast communication. The developed mobile application helps to monitor the soil parameters remotely. The used solar power bank helps to reduce the power consumption. Therefore, the proposed system can be cost-effective solution to the problems of the farmers. These are the references followed for this work. Thank you. End of presentation. Sir, any question?
Sir, is there any question for the presentation?
Hello.
Yes, sir.
Ma'am, I have some questions. Why you guys are using the MQTT only?
Sir, because we can.
Do you know
so
the
that we
nature of
can.
MQTT? Nature of MQTT in it. So what type of protocol?
Sir, I don't have much knowledge about that protocol because that part is done by another author.
Okay.
I am
So
mainly focused on the
straightforward,
hardware.
somebody inform you ki we have to use these protocols, right?
Sir, initially when we are trying to building the connection between two nodes simultaneously, then we faced problems. That's why we choose to go for the MQTT
Okay.
protocol.
And you apply these implementations that is in a Python or say
Sir, Arduino IDE.
Arduino, okay. Arduino programming, no? Okay,
Yes.
so there is ready-made protocol that is simply you have to include that algorithm.
Yes, sir.
Fine. Okay, fine. The rest of things are good. And I would
Thank you, sir.
suggest you you just whenever you are presenting your research work or say kind of these things, so we have put up in the form of evidence in the sense citations or in-text citations or say
Okay.
slide citations. Hai na?
Okay, sir.
Okay, thank you.
Thank you, sir.
Okay, so thank you, ma'am. Now moving for our next presentation. David Koche, and he's presenting on comparative study for recommendation algorithms on health effects.
Okay.
Presenter, you may
Yeah.
start your presentation.
Yeah, I'm sharing my screen. Just a second. Is my screen visible?
Yes, it is.
Okay. Thanks a lot. So yeah, good morning to one and all present here. I am Devdutta Koche with my team members, Sujan Shetty, Akash Maurya from Vivekananda Education Institute of Society's Institute of Technology, and we are guided by Dr. M. Vijaya Lakshmi ma'am. So our topic is comparative study of recommendation systems on recommendation algorithms on Yelp dataset. So moving on, first let me define the specific scope of our problem statement and the definition of our problem statement. Yeah, just a second. Yeah, so basically, the goal of this work was to do a comparative study on multiple recommender systems which are used by other papers, which are not combined and not came into a particular small amount of review or summary of those particular models with the help of Yelp dataset. To be more specific and particular about this, we are trying to predict the user's rating from 1 to 5 on a restaurant which they would love to visit, and saying that 1 is the lowest and 5 is the highest. We have also used multiple recommendation algorithms such as matrix factorization and then baseline, normal predictor, and SVD++ co-clustering, and many more. Moving on. So now everybody knows that recommendation systems are not new. They have made their place firm in our lives. Every single site, every single platform has recommendation systems. Even from Netflix to Amazon, there are a lot of recommendation systems which affect our life. Just to tell you some facts, Amazon has 35% of its revenue coming from recommendation system. That's probably a huge amount of revenue and sales which is generated by recommendation systems. So yeah, the recommendation systems make a huge impact on our lives. So that's why we chose recommendation system as a work for research. Now, before moving on to all the models and stuff and the results, first let's talk about what a recommendation system is. Everybody knows it, but still there are two definitions to it. A recommendation system is basically either you predict a user's rating for a particular item, or else what you can do is just give the user a list of items in a sorted order. As we can see here, that either predict user's rating from item J for item J or list recommended items for user J. So these are this is what recommendation system does, and we can see the diagram here. This is a utility matrix in which these I's are the items. Just a second. Yeah, okay. So these I are the items and you are the users, and U2 has some rating for I2. And obviously, it might be possible that some users haven't rated any items or something like that, which I'll cover in the further presentation. So yeah, based on that, we predict the rating or we predict the items and we recommend it to the users, which is that give a top n list or either predict the ratings of the user to the items. So yeah, this is what recommended systems are. And there are two recommendation systems, content based and collaborative based. Content based are work on item similarities, and collaborative based work on user item similarities, in which user similarities, in which if a particular user likes something and is a friend of yours, then you also might like whatever he likes. So that's how collaborative works. But yeah, that's an overview of the types of recommendation systems. The dataset we used is Yelp dataset. Yelp is a platform in which people review different websites, different restaurants, different stores, different platforms. And this dataset is collected over 8 metropolitan cities. And a lot of businesses and a lot of reviews are there, with also some stars given on a scale of 1 to 5, which I stated earlier. So that's our dataset. First, let us model the problem statement in our diagram here. So consider that these are users and these are items. A user likes an item on a scale of 1 to 5, and this is the rating which he has given to this item. Okay. So similar, this user has given 1 here, and other users have given some other ratings. Now the thing here is that we want this empty block to be predicted and get the value of this prediction for this user, so that if it is above some threshold, we can recommend it to him. And if he likes, then he can utilize the recommendation system. So this is a normal recommendation system, which is followed by mostly all the papers and all the references, like Koren Yehuda's paper in 2009, which is probably the most famous paper in recommendation systems. So, but yeah, what we have done here is that we have modeled it into a graph format in which there are item nodes and user nodes, where user node is rated and linked to item node, which has a weight of the rating given by the user. So considering that this is a weighted bipartite graph in which users are connected with other nodes, and the edge between them has a weight of the rating. Now we want to predict the edge to an item which has no weight, or else there is no edge between these two, this user and this item, then we need to predict this. That's the scope of this problem, and do a comparative analysis of all the models. Yeah. And you may ask, why is graph better than simple matrix format? Yeah, obviously graph is pretty much faster than the normal SQL tables. Also graph is scalable. We can do real-time queries if we want. We also can perform a high threshold and low latency outputs, get the high throughput and low latency outputs from the graph databases. So yeah, that's why the reason this graph is more better. Also, coming to the graph based format, which I told, there are almost these number of user nodes, which is almost 21,89,000, and these number of businesses. So this is the model which you can see, that a user reviews a business. Reviews is the edge pointing towards the business, and this is weighted edge. So yeah, we can see Tom and L are 2 users from reviewing a restaurant which is Tropical Smoothie C, and yeah, probably these 2 might like these, and if they like this, they might like another restaurant too. That's what collaborative filtering does. Now, problems with the data set which we figured out was sparsity, cold start, and gray shift. Sparsity is that obviously not all users have rated all restaurants. So basically there are a lot of edges missing, which we need to cover and which we need to predict, which is probably 99.9% edges in the data set. And cold start is that there might be some users who are new to the platform and who have no history of theirs. So this might be a problem to user, and this might show some vague predictions, or else because there is no history, there is no sense in predicting for him. So yeah, that's what cold start means. And gray shift is unpredictable ratings. Obviously that there are some people who are who have some particular taste and who don't like to rate above 5 or above 4 or above 3. They are too pessimistic about it, and so yeah, that's the gray shift problem, which is noted here. Now coming to algorithms, just a second. Yeah, coming to algorithms, We have used in total of 5 algorithms. One is baseline algorithm. This method is similar to the baseline approach used in the references, which is listed in Koren and Igeuda's, which was a collaborative filtering paper, and which is it says that it does not say, but it is that the model enables us to identify the part that truly represents the user business interaction. That's what baseline is. And similarly, normal predictor matrix decomposition is the most infamous algorithm used, which is basically dividing a simple matrix into multiple matrices and then multiplying it together to get all the links and predictions. So yeah, these are the algorithms which we have used. This is just a simple overview of how an rating looks like. So this is an user ID, this is an business ID, item ID, you can say that. And this is the estimated rating, which is 4.12185. So it is, if it would have been above the threshold, that is 4, then we might have recommended this item to that user, which basically seems to be much senseful. And so yeah, that's that. And for performance measure, we have used RMSEs as it is predicting some values, and there are some values already in the data set. So yeah, RMSEs are used. And coming to the results, baseline algorithm performed very well in comparison to normal predictor, SVD and SVD++ and co-clustering. Baseline was 1.18 for Austin. Austin is a city in the data set, and Portland is city on another data set. The reason we took it was that Austin and Portland had a lot of restaurants. So yeah, baseline was the first, and the SVD was the second. SVD, we expected SVD to perform well because it was a better method compared to a baseline, but still, baseline did give a better result. It might be that the data is small or there is a lot of sparsity in that, but still SVD and baseline were analogous. So yeah, this was the comparable result. And you might also ask why comparative study and why not individual models. The reason is that comparative analysis gives you an overview of different models which businesses might use or researchers might use, which makes more sense than performing only onto a single model. So yeah, addressing the cold start problem, consider the user is new. What would you do? The first thing which came to my mind was that give the best restaurants who have the most number of reviews and is above some threshold. So we can see that we have he has some interest in burgers. We got the average rating here and we put it out here. So yeah, he might like the arrogant butcher and something like that. This is how we can address the cold start problems. And coming to the future scope, which we had already implemented but couldn't take out in this put it on this paper, was that we can use Neo4j and leverage Neo4j services. We can use big data tools. With this this work was limited to 2 cities only. We can use a lot of cities and do a more analysis on that. And the conclusion was that we are able to predict 99% sparsity. As I said, this matrix was sparse, but still we were able to predict every single rating from particular item to particular user. And obviously, as I said, you can use Neo4j services and recommendation-based similarity matrices like cosine similarity, Pearson similarity. That's some other part, but still that has some weight on it too, because we tried it and it works, but we could not put it on this paper. So yeah, these are some references here. As I said, Koren, Yoda, and then the latest references are listed here on 2021 and 2022, which are graph based, which can be improved and put it onto the paper to get better results. And thank you for your attention. Are there any questions from the judges or the panel? Am I audible?
Yes, you are.
Okay, yeah.
Sir, is there any question for the presenter? About the presentation?
Hello.
Yeah, hello, sir.
Okay. Just go back, go to reference, list of reference.
Okay, sir. Just a second. Yeah, I'm here, sir.
Okay. Are they? I think it is not formatted, na? That's why it's look like this way.
Yeah, actually, sir, I forgot to bullet it in the last.
That's okay.
Minute.
Okay.
Sorry,
But
sorry for that.
next time do it. But
Yes,
that's
sorry
why
for
I'm
that.
worried about that one.
Yeah, yeah.
Whether you use the correct references or not.
Yeah,
Okay,
sorry,
fine.
sir. Sorry for that.
Okay, thank you. The rest of things are good. Okay.
Okay. Thank you, sir. Thanks a lot.
Okay.
Thank you, dear presenter. And now I sincerely thank our all authors for their excellent presentation during this session and their contribution to the session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you all for the support during this version of the conference and the previous 6 version of the conference. We will be happy to have you all in the 8th version of the conference in 2023. And all the presenters will be getting their digital certificate through email within 2 working days. Further, all the papers have been already forwarded to the speaker. Yeah, then publication will be live within 5 to 6 months, so kindly cooperate with the team ICT4SD 2022. And I also thank our session chair for chairing the session. And there is a token of appreciation to the chair on behalf of team ICT4SD 2022 and to Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you, sir.
Now, I would like to request you all to come on your camera to take a quick snapshot for the virtual memory session. Please turn on your camera. Thank you all, and thank you so once again.